Hey guys, we have this iPhone 7 here that is not displaying any image. The phone does turn on. We were just using our flashlight to confirm it's a no image issue and not a no backlight issue. It has been confirmed, and now we are going to look at the main board underneath our microscope and see what's going on here. We're going to zero in on the LCD FPC connector, and we're going to start by doing a visual inspection. We do notice some corrosion in the top right section of the FPC connector. But we're going to switch over to ZXW to compare the known good diode mode values on each pin, and we're going to check in we're going to check in ZXW here and pull up iPhone 7 and zoom in. We have our known good diode mode readings here. We're going to now check these on our customer board with our multimeter and diode mode. We're going to run through each pin and see if we find any abnormalities. That way we can chase where the problem is coming from. Checking all the pins, we notice that everything checks out fine and there are no abnormalities. So we clean off that corrosion and then we plug in our iBridge. This is going to allow us to test voltages on these pins. We do find abnormalities on pins 1, 3, and 5, and chasing where those pins go, they lead to U3703 backlight driver IC chip. So now we know likely where our problem is. We're going to pull this sticker, and sure enough, we do find some severe corrosion in the area. So using 99% isopropyl alcohol, we'll clean it off and zero in on the U3703 display driver boost IC. We're going to take some quick readings to see if we have any obvious shorts. We don't find anything, so the next step here is going to be simply replacing that IC chip. So we're going to put the board down here and grab our hot air station and set it to 350 degrees Celsius and 50 airflow. We're going to heat up the general area of the board. Then we're going to hold the chip and heat directly onto the chip and let the board fall once the solder reaches melting point. And we see that beneath the chip is severely corroded. So we add some low melt solder and clean up the pads, preparing to install a brand new display boost driver IC chip. Using hot air and wick, we finish off cleaning the bonding pads so they're flat and even, and then we can install the brand new IC chip. But first we take some quick diode mode readings of each of the pads to make sure there's no further problems. Comparing the diode mode reading values to ZXW, they match up fine, so that means we are safe to proceed with installation of the new IC chip. Here's our new IC. Going to orientate it correctly and add some flux and place the IC onto our customer board, and then grab our hot air station once again at 350 degrees Celsius and 50 airflow, heating the general area and then focusing heat directly onto the IC chip and giving it a light tap, watching it move back into place. We know that it has been successfully installed, and now we are ready to test the device. We place the board onto this metal block which dissipates the heat very quickly from the device, so we don't have to wait an extended period of time for the board to cool down. And now we can put the board onto our mat and plug in a known good screen assembly for iPhone 7, and then grab our DC power and hook it up to the device. Now that that's done, we can prompt to boot, from our DC power supply and see if we get image. We see our Apple logo, which means that image has been restored on the device following the repairs. Thanks for watching.